This is a 6.5 and 7.7 review. Calculators are not allowed, and we're looking at number 4. In all of these problems, A, B, and C, we are finding the average value of a piecewise function on an interval that spans the joint. So what that means is we're going to have to accumulate the two different branches and then multiply by that coefficient out in front. So let's remember that an average value of a function is going to always be 1 over b minus a times the integral from a to b of the function itself. Now, we are not able to accumulate or find the antiderivative of this function in one step because the function has two different expressions depending on which branch we're on. So what we're going to do is this coefficient out in front is not going to change. That's still going to be there, but in order to compute this integral, we're going to have to split it into two because we'll be on two different curves. So first, let's look just at the front. This is plus a 3, and we want a common denominator, so we can put these together. It looks like I'm going to have a pi plus a 12 over 4 on the bottom. So that means I'm really going to have a 12 over, or excuse me, a 4 over a 12 plus a pi. So that's the coefficient that's out in front, and then what I have inside is going to be the accumulation from negative 3 up to the joint, which is 0 on the first branch, plus the accumulation from 0 continue on to pi over 4 on the second branch. So if I do the antiderivative now, I'll have that 4 over 12 plus pi, and then in here I'll say, what did I take the derivative of with respect to x that gave me this? Well, that's an x cubed minus a 4x. I'm evaluating that from negative 3 to 0. Then I'm going to add what I took the derivative of with respect to x that gave me secant squared, and that's a tangent of x that then gets accumulated from 0 to pi over 4. So if I finish this up, I have a 4 over a 12 plus a pi, and then inside I have a 0 minus, if I plug in a negative 3, that's a negative 27 plus a 12, and then I'll add the tangent. Tangent of pi over 4 is a 1, tangent of 0 is a 0. So put this all together, I have a 4 over a 12 plus pi, and then it looks like a negative 27 plus 12, that is a negative 15, that's a positive 15, plus a 1 is a positive 16. So 4 times the 16 gives me a 64 over a 12 plus pi. So now let's look at B. On B, same process. We're going to have 1 over b minus a times the accumulation from a to b of that function. And because the function is piecewise and we have straddled the joint, we're going to have to break that integral into two pieces. So first, let's get a common denominator here. I'll multiply by 2 over 2. So I have a 3 pi plus 4 on the bottom, and on the top I'll have a 2. So now let's look at breaking up this integral. I will accumulate from negative 2 up to 0 on the 2x minus 4x cubed, and then I'll pick back up again at 0 and continue on to 3 pi over 2 on the sine of 3x. So I now need to find the antiderivatives. Antiderivative of this one is an x squared. This one is a negative x to the 4th. That gets accumulated from negative 2 to 0. Then I add the antiderivative of a sine is a negative cosine of the inside unchanged divided by the derivative of the inside. We can kind of shortcut that u substitution because the derivative of the inside is just a constant. So I'm going to work with it that way instead of going through the whole thing that I normally do. So if I finish this up, I have a 2 over a 3 pi plus 4. And then if I plug in 0, I get nothing. I'm going to subtract what comes out when I plug in a negative 2, which is a 4 minus a 16. Then I'm going to add what comes out when I plug in a 3 pi over 2. So the cosine of 3 pi over 2 is a 0. And then I'm going to subtract what comes out when I plug in a 0. When I plug in a 0, I get a 1, so I'm subtracting a negative 1 over 3. So let's put that all together. It looks like I have a 4 minus 16 is a negative 12. That makes it a positive 12. Plus a 1/3 is a 36 37/3. Which, if I multiply that out, will give me 74 over 9 pi plus 12. And we're done. Okay, last one, C. Same process. I have 1 over b minus a. Get a common, well, we'll worry about that in a second, times the integral from a to b of f of x with respect to x. We're going to have to split the integral because we're straddling the joint. So on here, let's get a common denominator. I need an 8 over an 8, so it looks like I have a pi plus a, and 8 pi gives me a 9 pi, and then on the top I'll have that 8, and then I'll break the integral into 2. I can go from negative pi up to negative pi over 8 on cosine of 4x dx, and then I continue on from negative pi over 8 to positive pi over 8 using the secant of 2x tangent of 2x. So I can shortcut the u substitution going backwards because the derivative of my inner function is going to be a constant, so I can just divide by that. So what did I take the derivative of with respect to x that gave me cosine? Well, that's sine of 4x over 4, evaluated from negative pi to negative pi over 8, plus, what did I take the derivative of with respect to x that gave me secant tangent? Well, that's the secant of the inside divided by the derivative of the inside from negative pi over 8 to positive pi over 8. So now I need to plug in. So if I plug in now, I will have the sine of a negative pi over 2. Well, the sine of a negative pi over 2 is a negative 1 over a 4. And then I'm going to subtract the sine of negative 4 pi, which is 0. Then I'm going to add the secant of pi over 4. So the secant of pi over 4 is the reciprocal of the cosine of pi over 4. So cosine of pi over 4 is root 2 over 2, so the reciprocal of that is a 2 over a root 2, and that's still over a 2. Then I'm going to subtract what comes out when I plug in a negative. So a negative pi over 4, the secant of that means I get the exact same thing since it's an even function. And so I end up with simplifying here, these cancel each other out, and this will give me, looks like a negative 2 over a 9 pi.